So probably about 15 years ago, research labs figured out how to use silicon to process light. That was kind of the birth of silicon photonics, where the photonics and the electronics were kind of being integrated into a single chip called a silicon photonic integrated circuit. Silicon photonics is now being adopted in the industry to help chips communicate with the world around them. And one of the ways that they're doing that is by constructing multi-chip modules. So multi-chip modules are going to have complex ASICs in the center of the module. And then around the perimeter of that ASIC is going to be silicon photonic integrated circuits. Those silicon photonic integrated circuits are going to convert electrical communication in the form of electrons into optical communication in the form of photons. The industry is really motivated to move the transceivers from the faceplate inside the multi-chip modules because of the power consumption. It's kind of surprising, but one of the largest power consumption devices in the data center is driving the high frequency digital signals from the switch ASIC or the CPU and GPU to the faceplate. That consumes a lot of power inside the data center. That data has to, or the heat has to be taken away. It's got to be cooled. And so they'd like to eliminate that power consumption. And one of the ways that they can do that is move the transceiver from the faceplate into the multi-chip module. And now they're covering those centimeters of distance from the faceplate to the multi-chip module optically, which doesn't consume power. So it can save power inside the data center. That's one of the motivations for co-packaged optics, where the transceiver is moved from the faceplate into the multi-chip module. So the adoption of multi-chip modules with co-packaged optics and silicon photonic integrated circuits co-integrated together inside the module is really being driven by high-performance computing and artificial intelligence requirements. In the future, it's going to grow, right? Once you have the capability to co-design computation and optical processing, it's going to introduce a lot of new applications. Biomedical applications are expected. Quantum computing applications are expected, and all of these are in the near horizon, probably within the next 5 years or so. The real challenge with silicon photonic integrated circuits is how you get the light into the chip and get the light out of the chip. And it's really a problem of length scales. You have an optical fiber that's about 125 microns in diameter, roughly the size of your hair, and you're trying to couple that into light pipes that are built into the PIC that are almost like 100 times smaller. It really is a physical mismatch in dimensions. So one of the ways that researchers invented to do that was through a device called grating couplers. And grating couplers allow you to take light from an optical fiber and couple it into the chip through diffractive gratings. And that's now commonly referred to as vertical coupling. So the industry is really looking to maximize the number of fibers that can be connected to these multi-chip modules. And we're expecting it'll be roughly 1,000 fibers in a couple of years. And who knows where it's going to go from there.